than atoms. All right, so subatomic. Sub means below the atom size. So they're going to be smaller than atoms. They are the parts of the atoms. Again, your prefixes, your suffixes, and your root words are going to get you through any biology. So if you have not or don't have it in your schedule to take medical terminology and you're going into the medical field, please think about trying to add that in because it will save your life down the road. Trust me. Atoms are composed of protons, neutrons, and electrons. Again, protons and neutrons hang out in the middle. We don't mess with those. You start messing with protons and protons and neutrons, we start having boom boom explosions. All right, we don't do that. We can mess around with the electrons on the outside. In the nucleus, protons are positively charged. They have a little positive charge to them. Neutrons are neutral, so they don't have a charge. They're very neutral. They're not positive, they're not negative. And electrons are negative. Electrons are constantly in motion. They're constantly going around just like this. They don't even get dizzy and fall down. It's crazy. All right, so for my visual learners, especially atomic structure, what do these subatomic particles look like? What's the charge? What's the location? I actually like to print this out and I like to cut it out and then I like to use it kind of like as a little puzzle that I can put together. So the subatomic particles, or the smaller than an atom particles, are protons, electrons, and neutrons. Pro, positive. Neutral, neutron, neutral. Electron, negative. The way I always remember this is if I got electrocuted, it would probably be a negative experience for me. I don't know. Willing to try, I think. No, I'm just kidding. Location, protons and neutrons. Again, if we have it, the P's and the N's, or the protons and the neutrons, are going to hang out in the middle, and the electrons are going to go floating around like this. These little outside circles where the electrons chill out are called orbitals because they orbit or go around in circles. Here's another picture of it. Got some protons and neutrons in the middle, and those electrons out there hanging around. All right, so some vocab for you. Atomic number. Atomic number is always the whole number. So if you look on your periodic table, if you Googled it real quick and you look on it, you'll see there's usually a whole number and a decimal number. Some of them out there may round that decimal up. So you want to find one that has the whole number and the decimal number. The whole number is going to be what's called the atomic number. This is going to tell you how many protons are in the element that we're talking about. This one is neon. So neon has 10 protons because that's the atomic number. The really cool thing about the atomic number is it also tells you how many electrons you have, which is the same number as protons. So you have 10. Atomic mass is the decimal number. That is going to be a combination of protons and neutrons. So in neon there, you have roughly 20.18-ish protons and neutrons in there. It gives you the total of the things together. The really cool thing about this is we already know how many protons neon has. So now we know the number of protons and neutrons. So what we do is we take that decimal number and we round it. So it would round to 20. We take the only other number we have in this math equation. We take it away. This is the number of protons. This is the number of protons and neutrons. So this is going to leave how many neutrons we have, which is 10. So neon, we know, has 10 protons, 10 electrons, and 10 neutrons. Krypton, let's look at this one. Whole number is the atomic number. Tells you right then and there. You have 36 protons and you have 36 electrons. Because unless you are told otherwise, and that's usually in chemistry when this is told otherwise, you're going to have the same number of protons as you do the number of electrons. The only other thing we haven't found is the number of neutrons. How do we do that? We take the only two numbers we have. The big number, we're going to go ahead and round that, which is going to be 84. And we're going to take 36 away from it. I'm going to do it like this, sorry. I really have to do it like long ways, guys. Okay. I'm not a math whiz. Don't come at me for some math, okay? All right, so the number of neutrons in there is going to be about 48. And the reason that you have this weird decimal, because protons, they're not in chunks. It's either a proton or it's not. Neutrons aren't parts of a neutron. It's either a neutron or not. The reason we have this is because they're called isotopes. Sorry, they're called isotopes. An isotope is an atom with the same atomic number, but sometimes their masses look a little bit different. So all over the world, people have found carbon. And when they run them through all these computers, sometimes we get back slightly different numbers. Does that mean it's not carbon? No. It just means that it's a carbon that's a little different from the other carbon. These are called isotopes. So they have different numbers of neutrons. Protons are the same, electrons are the same. It's carbon. But for some reason, their neutron numbers may be a little different. So looking at carbon, 6 is the atomic number. See how every single one of them have 6? So that means carbon has 6 protons, 6 electrons, and neutrons are going to be a little bit different. This one has a mass number, or an atomic mass, of 12. They went ahead and rounded it for you already. So how many neutrons do we have? We take the big number, we minus the little number, and that's going to give us the number of neutrons. We have 6. This carbon, found in a different place, has 13 protons and neutrons together. So we take that number, we minus the atomic number we have. This one is going to have 7 neutrons. This one's going to have 8 neutrons. Are they all carbon? Yes. They all have the same atomic number, 6. Yep, all the way across the board. But they just have slightly different numbers of neutrons. It's just a natural occurrence. This is where we get the lovely decimal number. Been a long day, sorry guys. It's been this decimal number. Because when you average out the 12, the 13, and the 14, and maybe you found 100 different carbons somewhere, you're probably going to get a number when you average it out that's a decimal. That's why it's okay to say, okay, this is 83.8. We're going to go ahead and round that up just to 84. Same thing with neon. We got about 20.18-ish. Well, we actually can round that down to just 20. Make it a little bit easier. Here's a good picture of the periodic table. When you're looking at each one of these, let's look at carbon right here. Low carbons and everything. You have carbon. You have your atomic number of 6. You have atomic mass of 12 point, it's like 011, I think. All right. Looking at this, I need you to tell me the pin, the PEN. How many protons? 6. How many electrons? 6. Take the big number and go ahead and round it. So we have 12 minus the only other number we have, 6. And then we have a 6 there. So carbon has 6 protons, 6 electrons, and 6 neutrons. All right, let's look at oxygen. Go ahead and draw this. We have oxygen. The atomic number is 8. It's our whole number. The atomic mass is, whoops, 1 second. It's right near my little things that I'm over here. Okay, I gotta write it over here a little bit, sorry. 15.999. Okay. So again, what is my PEN? What is my protons? How many do I have? How many electrons do I have? And how many neutrons do I have? How many protons? 8. How many electrons? 8. Round this to 16. Big number minus the small number. 8.